What is a limit in maths? Picture a square on the screen. Slice it straight down the middle. Now take one of the resulting rectangles and slice that down the middle too. Repeat this process again and again. With each cut, the new slice becomes thinner and thinner. Intuitively, the area of each slice is getting closer to zero, but it never actually reaches zero. That creeping, never quite arriving idea lies at the heart of what we call a limit. In everyday algebra, we plug a number into a function and get an output. For example, if f of x equals 1 divided by x, then when x equals 2, f of x equals 1/2. A limit asks, as x gets closer and closer to 2, what does f of x get closer and closer to? For this function, the answer is also 1/2, but the shift in focus matters. A limit describes how a function behaves on the way to a point, not necessarily at the point itself. This becomes really important when the point we care about is awkward or does not even exist. Take x equals infinity. Infinity is not a number we can substitute into a function, yet we can still ask, what value does f of x approach as x grows without bound? For our example, as the denominator gets bigger and bigger, the fraction squeezes ever closer to zero. We say the limit of f of x as x approaches infinity is 0. In mathematical language, the limit of f of x as x approaches a value a equals L if we can make f of x as close to L as we like by taking x sufficiently close to a. To recap, limits capture approach, not arrival. They show how a function behaves near points where direct substitution is difficult, undefined, or impossible. Mastering them unlocks derivatives, integrals, and the rest of calculus.